Did you know there's a paradox so mind-boggling it threatens to rewrite physics? It goes by the name the Cronon destruction hypothesis. And no, it's not science fiction. We're diving into the realm of quantum mechanics, where time, as you think you know it, starts falling apart. Let me explain. Picture this. You're familiar with particles like electrons, protons, and quarks. But have you ever heard of theoretical particles called instantons? These aren't your average particles zooming around in space-time. Instantons exist, not over time, but in a frozen snapshot, like static pictures in the 4D Minkowski space-time framework. Simple enough, right? Well, here's where it gets wild. According to this theory, if one very specific kind of particle were to form, a highly improbable Cronon collider event, the concept of fixed timelines could collapse entirely. What's that mean? Think of time less like a stretched-out piece of string and more like a fine fabric with quantum threads woven together. If this particle appeared, it could hypothetically yank apart certain threads, shredding what we call causality. Events wouldn't move forward in a neat order anymore. Imagine knocking over a glass of water today, but the glass doesn't spill until 2 years ago. That's the timeline chaos we're talking about. But is this realistic? No one's observed a Cronon event, or even proved that these particles exist. They remain purely theoretical, like tachyons, which move faster than light. Yet, equations from quantum field theory suggest such events could be mathematically possible. And these equations don't just come out of thin air. They sit deep in our frameworks for understanding forces like electromagnetism, or even the glue holding together atomic nuclei. Here's a practical example. The Large Hadron Collider experiments have smashed particles to recreate extreme environments, but so far, no timeline-destroying events. Think of it like following the user manual for every possible scenario, except skipping the one chapter that had accidentally opened Pandora's box. Some physicists argue theories like these help us probe the boundaries of reality itself and understand why it holds together at all. So, are you safe from a time catastrophe? For now, sure. But unraveling time could tear physics down to its very core. If you're hungry for more short or in-depth dives into advanced physics, tech, and philosophy, subscribe to Hyperfocus. I'll see you there.